Hello and welcome to another edition of 5th grade math. I'm Mr. Manella and joining me today is a young man who is ready, willing, and able to learn. Yeah? How you doing today, Stu?
Know it. I am fantastic.
Good. How was your Zoom band practice?
Oh, so good. We came up with 2 new songs.
Wow, 2 new songs. What are they called?
Ewok the Party and Baby Got Snacks.
Baby Got Snacks. How's that go?
I like big snacks, I cannot lie. All you other Muppets can't deny.
Okay. I got it.
Yeah.
You've
I like big snacks.
You've been watching 90s hip-hop YouTube videos again, haven't you?
Man, all day.
I mean,
so good.
A classic is a classic.
Classic.
But let's keep this child-friendly and,
yeah, big snacks.
Well, yeah.
Family-sized Takis.
That's true, and this is a family program.
Yeah, it is.
Okay.
About fractions, right?
Yeah, fractions. Okay.
Still on fractions.
Yeah. You ready to learn more about fractions?
So ready.
Okay, let's learn more about fractions.
Are money and pizza going to be involved?
Probably.
Yeah.
Let's find out. Okay, so in our last lesson, we learned how to add fractions with the same denominator, like 1/10 plus 3/10, which gives us 4/10. But what do we do when the denominators are different?
You just forget about it and go listen to music.
Hey, get back here! You don't get to quit just because it's hard. That's not how learning works.
Oh, fine.
That's better. Let's say we have a problem where we have to add 1/2 and 1/4. Can we just add the numerators and the denominators and call it 2/6?
Well, we didn't add the denominators before, so I don't think it would make sense to do it now.
That's right. We never add denominators and fractions. Never, ever, ever.
Ever, never,
Ever.
ever.
You will never add a denominator.
Never.
But before we can add the numerators, the denominators need to be the same. Let's use another Sicilian pizza as an example.
I'm starting to get hungry.
Hang in there, you'll make it, okay? Here's half of the pizza, and here's 1/4 of the pizza, okay? So now they both come from the same whole pizza. So we can definitely add them, but we need to make the pieces the same size first. This means getting a common denominator.
Oh man, I don't even know how we're going to do that. How are we going to do that?
Well, there's a couple of different ways, but today we're going to focus on turning one denominator into the other.
Like morphing?
Kinda, okay? The way we do that is to look at our denominators and see if the smaller number can turn into the larger number by multiplying. Can you turn a 2 into a 4 by multiplying?
Oh yeah, 2 times 2 is 4.
Okay, so let's do that to 1/2. We're going to multiply the numerator and the denominator by 2 to get a new fraction that is worth the same amount. Let's do that now.
Whoa.
What?
If you multiply it by 2, how is it the same amount?
Good question! We're not going to actually multiply it by 2. We're going to multiply it by 2/2, or 2/2, which is a fraction that has the same numerator and denominator. What do we call a fraction that has a numerator equal to the denominator?
Oh, whoa. I remember. That's 1 whole. So we really just multiplied by 1.
Exactly, and we get 2/4. The cool thing about 1 is that you can write it as any fraction you want as long as the numerator and the denominator match. I like to say it's like having a matching pants and shirt, right? You got to have the outfit that matches, but 1 whole can wear any outfit it wants.
Oh, I cannot relate. I do not wear pants.
Yeah, well, you don't have legs either, so it's fine. Okay, now when we change a fraction by multiplying by 1 whole, this is called getting an equivalent fraction, which means they are worth the same. 1/2 and 2/4 are the same thing. So now we can add them together and get 3/4.
I still need to see more of this, and so I demand that we retire to the whiteboard.
In what world do you get to make demands?
Okay, can I ask nicely?
Try it.
Hey, can we go to the whiteboard, please?
Sure. Let's do that now.
All right.
Okay, so when we add or subtract fractions and the denominator isn't the same, we have to make them the same. That's called getting a common denominator. We need to do that before we can add or subtract. Now, we always want to check first if we can turn one into the other. That should be the first question you ask yourself. Can I turn the smaller number into the bigger number by multiplying? Can you multiply and turn a 3 into a 6?
Yeah, because 3 times 2 is 6.
Right, so what we're going to do, every time you add or subtract fractions, if the denominators aren't already the same, you're going to make 2 new lines for your new fractions and 1 more line for your answer, okay? And then your new denominator, or your common denominator, because in this case it's not going to be new for the 6, is going to go in all 3 places, okay? So you said we can turn a 3 into a 6?
Yeah. If
Okay.
you multiply 3 times 2, you get 6.
Okay, so that means that 6 is going to be our common denominator. Now,
Oh, I see. You set everything up so you can fill it in.
yeah, okay, now did this
Oh.
6, and bear in mind, like when you put your new fractions over, don't change the place whether they're first or second, okay? This one's second, it's going to stay second. Now, in addition, it won't matter, but in subtraction, it absolutely will.
Oh,
So
yeah.
do not change the order of your fractions. Now,
Okay.
this 6, did he change his pants?
Nope. He kept his pants the same.
That means he's going to keep his shirt the same too. So what's his
Oh.
shirt going to say? It's going to stay what?
It's just going to stay at 1 if it doesn't change.
It's going to stay as a 1, right? Okay, now,
Okay.
this is where things get a little bit different. Okay, I'm going to change
Okay.
colors on you.
Well,
All right? How did 3, and I like to draw these lines here to remind me what went where. How did 3 turn into 6? What did we multiply by?
oh, yeah, that line helps me connect them. But we multiplied it by 2.
We did multiply by 2. So I read a times 2 in there. Now, whatever you do to the denominator, you have to also do to the numerator to make sure that you're multiplying by 1 whole. So,
Okay.
how did 1 change? Because it's going to change the same way that 3 changed, times 2.
Okay.
So what is it going to become?
Well, if we are just multiplying it by 2, it's 2.
It's 2, right?
1 times 2 is 2.
Right, so now we have a matching denominator, a common denominator, which means we can just do what?
Well, we can just add the numerators.
Just add the numerators. What's 2 plus 1?
3.
3/6, okay?
Whoa.
1/3 plus 1/6 is 3/6 because we turned 1/3 into 2/6, and now we can add them.
Wait. So like that 1/3 is the same as 2/6?
Yes,
Is that
they
what
are.
you're saying?
They are equivalent fractions. We took the 1/3 and we multiplied it by 2 over 2, which is 1,
Okay.
and we got 2 over 6.
Oh.
Because if you have 1 out of every 3, which is what this fraction means, then you have 2 out of every 6.
Oh. Or like with the dollars. If we had 1/3 of a dollar, we would be the same as 2/6 of a dollar.
Right, although that would be like a weird fraction of a coin that we couldn't actually have.
Yeah.
So like if we had 1/4 of
Yeah.
a dollar, okay,
Yeah.
then we would also have 25/100ths of a dollar. Because
Right.
we would take 1/4 and we'd multiply it by 25
Oh.
over 25.
Oh.
And 4 times 25 is 100.
Yeah.
And 1 times 25 is 25.
So we're doing that whole equivalent fractions
That is
thing.
exactly what
They're
we're
the
doing.
same amount.
Indeed it is. So
But
let's-
now the denominators are the same, so we can just add the numerators.
Yes.
We just had to do a little switcheroo first.
Yeah, well, don't worry. We're going to do another one. So you got more time to practice on this, okay?
All
All
right.
right, so quick erase. Next problem.
Okay.
It's going to be
Bring it on.
7/8 minus 1/4.
Okay, I'm ready.
7/8
Uh-oh.
minus 1/4. Now, this is where it's going to be really important to not change the order of your fractions.
Oh.
Okay, are the 8 and the 4 the same?
No.
Okay, that means I'm going to have to set up the rest of my problem. Okay?
Yep, get it all set up for you.
Now, can I turn a 4 into an 8 by multiplying?
Yeah, I can multiply by 2.
Okay, so that's what we're going to do, right? We're going to leave the 8 the same. That's going to be our new denominator, our common denominator. It'll be
Right.
new for the 4. It'll be the same for the 8. Now,
Okay.
did 7/8 change pens?
Nope.
No.
Same.
That means that 7/8 is not going to change shirts either. Now, I can't
Oh.
put my 7 here because it's a
Well-
subtraction problem. My 7 has to go first. That's where it goes. Okay?
Okay.
Now, how did 4 turn into 8? What did we multiply by?
We multiply by 2.
We multiplied by 2, so we're going to do the same thing up here. And
I love those lines.
and what's 1 times 2?
It's 2.
It's 2. So now we can do 7/8 minus 2/8. Are we going to mess with the denominators?
No!
No, we're not.
Never.
But what's 7 minus 2?
Oh, it's 5.
So what's our answer?
5/8.
5/8. Okay?
Did we just subtract fractions?
We did, because 1/4, we multiplied it by 2 over 2, and we got 2/8.
Okay.
Because 1/4 and 2/8 are the same thing. Okay?
Okay.
Nothing else to equal there. I don't know why I wouldn't equal. I'm just getting so
Right.
excited about math. I
I
know. But 1/4 and 2/8 are the same thing. If you have 1 out of every 4, that
Right.
means you have 2 out of every 8. Okay? So, now we
So
subtract.
since they're the same, we can just switcheroo.
Right.
Okay.
So we didn't change who the fraction is. We just changed its clothing.
Right.
I'm wearing a different shirt than I was wearing last time. You're wearing the same one.
Always.
Yeah, we need to get you some new shirts.
Well, yeah.
I mean, I got some socks you could probably wear.
This one fits me like a glove.
Yeah, that's because you've never taken it off. It is like
I don't want to wear your socks. I just realized what you said.
Oh, you're too good for that. Mister, I made a turkey out of Takis and melted cranberry sauce.
That was epic.
I'm too good to wear a sock?
Yes.
Yeah.
Okay, so...
Buddy, there is literally nothing beneath you.
What?
Yeah, except a
There's
chair.
Table,
a chair is the only thing that's beneath you.
Yeah, and some crumbs.
Okay, fine. There are several things that are beneath you, and they are all more disgusting than one of my socks.
Oh, man.
All right, let's do another problem.
All right, let's do some more fractions.
Okay. Let's do another one of these.
Yeah. Yeah. So, some of them don't change their pants, and some of them do.
Right. Okay, we're going to get to ones where both need to change their pants in the next lesson.
Whoa.
But for this one, okay, we're going to look at 2/3.
Okay.
Minus, another subtraction,
Okay.
5/12.
E.
This is going to be a little bit different.
Okay.
Okay, now, first thing we ask ourselves,
Yeah?
can a 3 turn into a 12 by multiplying?
Yes.
But it's not times 2, is it?
No, that's why I had to think about it for a minute.
We don't always have to multiply by 2 to get an equivalent fraction.
Yeah.
So, 12 is going to stay our denominator, okay?
Right.
So, first thing we do, did 5/12 change pants?
No.
That means 5/12 is going to stay 5/12.
Not changing its shirt either.
Right. Now, how did 3 turn into 12? What did we multiply by?
It was by 4.
By 4, which
Yeah.
means we're going to do the same thing up here. 2 times 4. You can't just put a 4 here because this isn't a 1, okay? So
No.
in the last one, we just put the same thing we multiplied by up here, but this numerator is 2, so you need to do 2 times 4.
Right.
What is 2 times 4?
It's 8.
It's 8. So it's
Yeah.
8/12 minus 5/12. What's 8 minus 5?
3.
Are we going to mess with the denominator?
Never.
No. So it's
Okay.
3/12. Okay?
3/12.
We took 2/3, and we still multiplied it by 1, which was 4/4,
Yeah.
and we got 8/12.
Right.
Equivalent
Those are the
fraction.
same amount.
Fun fact, 8/12, that's my birthday.
What?
August 12th. Yeah.
Oh.
Yeah.
Yeah.
It was the first day of school this year.
Does that mean that February 3rd is your equivalent birthday?
February
'Cause look,
3rd.
2/3.
Oh, actually, well, I guess so, but February 12th is my half birthday.
Oh.
Okay, that's 6 months.
Oh man, we are way off the rails here.
Yeah, I stopped celebrating half birthdays when I was like 8, so I never really celebrated them.
Yeah.
You know, who wants to party in February? I mean, it's,
Valentine's Day.
yeah, well, that's February 14th. That's a different conversation.
That's
Okay.
a party.
Speaking of Valentine's Day, you talked to Gene lately with his girlfriend?
He's still up there. He had to quarantine to make sure that he wasn't sick. And so they're just cozied up by the fire in Canada.
Have you met her yet? Have
No.
you seen her on a Zoom or anything?
No. He said she naps a lot.
No, that's fine. That's the same excuse I use for you when,
What?
kids are asking about you at lessons. Yeah, kids ask about you a lot.
And I'm totally real.
Yeah, you are.
Just like Jean's girlfriend. She's definitely real. Right?
Is she?
I mean,
We're going to give Gene the benefit of the doubt.
Yeah.
Okay? Let's do one more fraction problem,
okay.
and we'll stop there.
Okay. All right.
This video is already going on pretty long. We did the whiteboard almost 10 minutes.
Oh!
I know, but this is important. We need to learn about this
Yeah,
stuff.
but we're on fire.
Yeah, we're doing a great job.
Yeah.
Okay, let's do one more problem. Let's do 1/2
Feeling pretty confident about fractions
plus
today.
3/10.
Okay.
Okay?
Yeah.
So, and we're gonna turn this into money at the end. It's gonna be fun. Okay, I'm
Oh,
gonna show you how to do
money!
it. Yeah, okay. So, can a 2 turn into a 10?
Oh, yeah.
Okay, so we're gonna make 10 our common denominator. Okay?
Yeah. So really, you just have to ask yourself at the beginning, can one become the other?
Exactly. That's the first thing you need to ask yourself. And if the
Yeah.
answer is yes, then you
Then you
leave one of
fill
them
it
the
in.
same. Right, now, did 10 change pants?
Nope.
So it's not gonna change shirt.
Not changing shirts.
Okay, now, how did 2 turn into 10 by multiplying? What did we multiply?
Multiplied by 5.
We certainly did. So now we're going to do the same thing to the 1.
Yeah.
What's 1 times 5?
It's 5.
Okay, so what's 5 plus 3?
8.
8. Okay, now, remember how we said dimes were tenths?
Yeah.
How much money is 3 dimes? What's it worth?
30 cents.
30 cents.
Yeah.
Okay, so that would be 30 out of 100.
Yeah.
Okay?
Yeah.
And half of a dollar, how much money would half of a dollar be?
Well, it's 50 cents.
It would be 50 out of 100. If we added them together, we'd get 80 out of 100, which
looks familiar.
Which is an equivalent fraction as 8 over 10, because if we multiplied by 10, sorry, we wouldn't have to multiply, we'd have to divide. Because, we're going the other way.
You're getting excited.
I know, but still, it's 8 out of 10.
Oh my gosh.
Yeah.
Oh, look,
8
5 tenths and 3 tenths is 8 tenths, and 50 hundredths and 30 hundredths is 80 hundredths. Whoa, equivalent fractions everywhere!
It's a lot.
It's like a pattern.
It's definitely a pattern. It's definitely a pattern. Proud of you, buddy.
Yes.
Yeah.
I remember.
Okay. You think you're ready for a recap?
Yeah, definitely.
Okay.
Recap.
Let's recap. Okay, so to recap, when you add or subtract fractions, and the denominators don't match, you got to get a common denominator.
Yeah.
Now, the first thing you need to ask yourself is what?
What?
What do you ask yourself?
Oh, can one be turned into the other?
Right, can one be turned into the other? And if you can turn one into the other, then you do that. Okay, you multiply the smaller one by a certain number to turn it into a larger one. If it's 2 and 4, you multiply it by 2. If it's 2 and 10, you multiply the 2 by 5. Okay?
But you got to do the same thing to the top and the bottom.
Exactly. Pants and shirt, got to match.
Yeah, got to match.
Whatever you do to the numerator, you have to do to the denominator. Yes. And then, once you have a common denominator,
where they're all the same,
you can add or subtract, depending on what the sign says. And pay attention to the sign. Every year, I see students do everything right, and then they add when they're supposed to subtract, or they subtract when they're supposed to add, and they end up getting it wrong. It's like you
brutal.
Yeah, it's like you drove to your destination, and then you fell getting out of your car. Don't fall getting out of your car. Okay.
Yeah.
All right.
Critical fail.
Okay.
Sad. Okay.
Yeah, and if you can't turn one into the other.
What happens if you can't turn one into the other? We didn't talk about that.
Well, that's something called cross multiplying. That's what you're gonna have to do, and we're gonna get to that in the next lesson.
Oh,
okay.
Cool.
Yeah.
Can I eat now? Because all this pizza talk has made me super hungry. I think I'm at... hey, do you want some of my leftover turkey with me? My tuck turkey?
Ew, no, there's still some of that left? Absolutely not. Thanksgiving was a week ago. Why are you still eating that?
My love for Takis never expires.
Yeah, well, you might if you keep eating old food.
Willing to take the risk.
Ugh.
No regrets.
Yeah, you're never the one who has regrets. Me? I got a few.
All right, well, I'm off. I got a taco turkey waiting for me.
Gross. Absolutely disgusting. This concludes our video lesson.
See you next time.
Bye.
Bye.